Hi, Devin Sol here. In this video, we're going to compare three different simulation software packages. SIMSOLID versus Fusion 360 versus SolidWorks Simulation Express. And we're going to use this model that I created called the water tower concept. And so we're going to put some forces on the top of the supporting structure for the water tank and see what we get. Here's some of the details about the water tower concept. The bottom of the tank is approximately 127 feet off the ground, and that's on purpose so we can see a value of 80 psi down at the bottom of the tank when the tank is full. The tank holds 1 million gallons of water and has a void space of about 10% to allow for contraction and expansion. I modeled this assembly in SolidWorks. I exported it out as a step file to Fusion 360, and I exported it out to SIMSOLID using an STL file. So here's the supporting structure. You see those 6 red beams and then the green outer collar. We'll run the first simulation in SolidWorks Simulation Express. We'll move over to Fusion 360 and we'll finish out by using SIMSOLID. Just for grins, the weight of the tank and the water inside the tank add up to about 9,500,000 pounds. So let's get started. In this assembly we have 3 main components: the frame, the water that's inside the water tank, and then the water tank itself. We'll be running the simulation on just this structure, this frame, that is going to support the water tank and the water that's inside of it. The approximate weight of the water tank with the water, about 1 million gallons in there, works out to about 9,500,000 pounds. And in the simulation, I will apply that weight to these 6 red structures on these specific faces that I just clicked on. So now I go up here to the Evaluate tab, and we're going to turn on Simulation Express Analysis Wizard, and we're going to run through this and see how it works out for us. So we click on the next button over here, and we're going to add a fixture. So the fixed part of this assembly would be the base right here, because it'll be mounted in a concrete pad, and that is designed not to move. So we click OK. We go back over here to the right hand side and click on Next, and we want to add a force. We want to add that force to these 6 surfaces, so I'll click those now. Then we'll go back over here and set some parameters. So we'll change this to English. We'll set the pounds at 9,500,000 pounds total weight on those 6 faces, and click the green check mark for OK. We'll go back over to the right hand side of the screen and click on Next, and just verify that I already chose the material, which is 4340 steel normalized. A little expensive, but got to be careful on these public projects. I'll click on Next, and now I'm going to run the simulation. And what is happening now is that SolidWorks is trying to mesh this model. Well, now SolidWorks has crashed trying to mesh the water tower support structure, so we'll close the program and let's go over to Fusion 360 and see what happens over there. Alright, we've got the supporting structure for the water tower concept open in Fusion 360. Let's run a simulation here. Let's see what kind of results we get. So over here in the top left hand corner, I pick the down arrow and I look for simulation. If I right click on studies and say new simulation study, we see the 4 different types of studies that are available currently in Fusion 360, and we want the static stress, so I'll click OK right there. Next, going back to the tree, the units are in decimal inches. That's perfect for me. Next thing I want to look at are the materials, so I want to check the materials and make sure that we apply the 4340 steel, just like we did in the SolidWorks simulation. Here's one. Say OK. Now we'll go up here to the top toolbar and start adding constraints. So the bottom of the structure would be fully constrained. We click on that face and say OK. Now we want to add the load. Again, the load goes on these 6 beams these radius beams, and it's kind of tricky to get the load going the right way. Let me put in the amount of force, which is 9,500,000 pounds. I have to make sure I got this right now. So I got 3 zeros, 2 zeros, there we go. Then I'm going to select user input on the direction of the force and click OK. I'll go to the front view, and you can see that the forces are angled, which is kind of weird. So if I go here to the load and I right click on force number 1, edit the structural load, I get this little slider, rotating slider, and then I remember that the value that goes in here is 32.5 degrees. Let me get this straight here and say OK. And let me flip it around a little bit. Well, that looks good enough for now. Let's go up here to the top. The traffic signal's giving us a green light. We'll click on it. First thing it'll do, it'll mesh. And let's see how long it takes to mesh in Fusion 360 versus SolidWorks. Okay, meshing 1001, 1002, about 2 seconds. That's fantastic. Love it. Here's a meshing report that I rarely save. So I'm going to close that. And let's go to the front view and spin it around, and sure enough the tower got bent over like the Leaning Tower of Pisa. Is it Pisa or pizza? Anyway, looks over here in the lower right hand corner, the software's telling us that we have a factor of safety of 15. That seems a little high to me. Let's see what other values we can see in here. How about displacement? According to this chart, the maximum displacement, which is red up here at the top, is only 161 thousandths. Man, that's fantastic for a huge water tower like this, and 0 right at the bottom. That looks good. Let's look at stress. I think all these stressor points right here were caused because the tower was bent over. I don't think they'd be there if it wasn't bent. Same with, we should see about the same thing in strain. Yeah, we do. So, goes very quickly in Fusion 360. I really like that. We have kind of two situations. We have a very quick simulation, but we have some questions about some of the results. So here's what we'll do next. We'll run the simulation in SIMSOLID, and then we'll see what we get there. So here we are in the SIMSOLID application, and let's run the simulation in this environment and see how it goes. So we want to run a structural analysis right here. So over on the left hand upper corner we see a structural analysis 1, and let me go back to the up the tree one step and assign the material. And we're looking again for 4340 steel normalized. There it is right there. It says apply to all parts, but this part, I guarantee you, is a single body, a solid model. There's absolutely no gaps. I modeled it to be that way on purpose. Now let's go back to the structural part in the tree, and let's start assigning the loads and the constraints. So we'll start with the constraint at the bottom here. Click on this bottom face and say OK. Now we'll put the load on there. And again, I'll pick these radius faces. 1, 2, 3, 4, 5, 6. I'm going to set the units for pound force and decimal inch. And if we look at this model orthogonally, the y-axis is the vertical axis, so we want negative 9,500,000 pounds in the negative y direction based upon this coordinate system right here in the lower left-hand corner. And now we say OK. And now we are ready to run the simulation. We click on this rocket right here, and then we look for results up here in the tree, and let's see how long it takes. Ready, set, go. Now there's a progress bar right down here, and I'm guessing that it takes longer to upload the model to the cloud server than it does to actually run once it's in the cloud. Okay, so we've got our result. That looks like about 45 to 55 seconds, which again is pretty amazing. So here are the results that we can view right here. So I click here, and I'm going to start with this displacement magnitude. Now it always goes back to millimeters. I don't know why it changes because I specified decimal inches. I'll change it again and say OK. Now the thing is, the simulation ran fast, but we got completely different values versus what we saw in Fusion 360. If you remember, in Fusion 360 we had the maximum displacement of only 161 thousandths with a factor of safety of 15. I find both of those values to be extremely optimistic. And yet here in SimSolid, it's like we get the opposite. We've got some pretty horrible numbers. So for example, the scientific notation, the maximum displacement magnitude is 9.76 inches. That's a lot, especially compared to the other simulation that we got in Fusion 360. Now the good news is down at the bottom of the support structure, we get a very, very small number, 6 places to the right of the decimal point, so that's virtually equal to 0, which is good. That's what we want. But I don't understand why we're seeing such a big difference in displacement from one software to another. Now that we've run the simulation in SolidWorks, Fusion 360, and SimSolid, let's do a post-mortem and look at the information and come to some kind of conclusion. Okay, let's summarize what happened with these simulation results. Number one, SolidWorks crashed. It was not able to mesh the supporting structure for the water tower concept. And I've been using SolidWorks now for about 17 years. The simulation, ever since it came out, I can't remember exactly when it came out, but I've been using it pretty steady for about 5 or 6 years. And this is a typical behavior for SolidWorks Simulation Express. It just doesn't have the horsepower or the software code to mesh about 85% of the parts that I try to run through this program, so that's very disappointing. Next we go to Fusion 360. The advantages of Fusion 360 is that the simulation software is included in the product. The user interface is excellent. The cloud enhanced simulation is fantastic. The speed is great. The setup is very fast, and the graphics are really nice. Again, I question the results. Two results that I have some questions about are the factor of safety, which was listed at 15, and the maximum displacement of only 161 thousandths of an inch. If those are true, that means that I have a great design for my water tower support structure. But let's move on and compare that to the results from SimSolid. The thing I like about SimSolid is it's available on a monthly subscription. I like the user interface. I like the fact that meshing is either hidden or taken out of the program, and once the model is uploaded to the cloud servers, the simulation runs very fast. Again, the results is what I have questions about. So in Fusion 360, we saw the maximum displacement at 161 thousandths of an inch, yet in SimSolid, we see 9.7 inches. That's a huge difference. And so now I have conflicting information about whether this supporting structure is actually viable. So I hope you have enjoyed this comparison between 3 commonly used simulation products. I'm fascinated by simulation, and I try to use it as much as possible. So thanks for watching. If you have any questions or comments, please contact me anytime. Here's my contact information. I recently updated my website, and I look forward to hearing from you. Thanks for watching. See you later.